In this video, we will go for Kennedy's theorem. Consider three planar bodies P, Q and R. On screen, planar body P is shown and it is fixed. Above it, we are having planar body Q, which is rotating about point A in anticlockwise direction. Means we can say there is a turning pair between planar body P and Q at point A. Planar body R is shown and it is rotating about point B in clockwise direction. Means we can say there is a turning pair between planar body P and R at point B. Here we are having three planar bodies or links P, Q and R. Hence number of ICRs will be given by relation n is equal to n into n minus 1 divided by 2. But number of bodies or links is 3, therefore number of ICRs n will be equal to 3 into 3 minus 1 divided by 2, therefore number of ICRs n will be equal to 3. Now we will write those 3 ICRs. For links or body, we can write P, Q and R. In next row, we can write ICRs as IPQ. Next one will be IQR. While in last row, we can write ICR IPR. Now we will locate or mark these 3 ICRs. At point A, there is a turning pair between planar body P and Q. Hence, ICR IPQ for relative motion between body P and Q will be at point A. At point B, there is a turning pair between planar body P and R. Hence, ICR IPR for relative motion between body P and R will be at point B. We have located or marked two ICRs IPQ and IPR. Now only one ICR is remained, that is IQR. Hence we will try to locate ICR IQR. At ICR IQR, relative motion between Q and R will be 0. Hence it can lie either on body Q or on body R, or IQR can lie somewhere else, as we can assume any shape for link. For time being, let us say ICR IQR will lie either on body Q or on body R. Hence, we will consider region where body Q and body R are overlapped. In that region, we will mark ICR IQR. For the sake of simplicity, for that point, we will also use notation C. ICR IQR can lie either on body Q or on body R. If IQR will lie on body Q, which is rotating in anticlockwise direction about center A, then velocity at ICR IQR, that is VIQR, or velocity at point C, that is VC, will be given by relation VIQR or VC is equal to AC into omega Q, where omega Q is instantaneous angular velocity of planar body Q. Therefore, we will have relation like this: VIQR or VC is equal to distance between ICR IPQ and IQR multiplied by omega Q, and its direction will be perpendicular to AC as shown on the screen, as body Q is rotating in anticlockwise direction about center A. ICR IQR can lie either on body Q or on body R. If IQR will lie on body R, which is rotating about center B in clockwise direction, then velocity at ICR IQR, that is VIQR, or velocity at point C, that is VC, will be given by relation VIQR or VC is equal to BC into omega R, where omega R is instantaneous angular velocity of planar body R. Or we will have relation VIQR or VC will be equal to distance between ICR, IPR and IQR multiplied by omega r, and its direction will be perpendicular to BC as shown on the screen, as body R is rotating in clockwise direction about center B. But same point, that is ICR, IQR or C, cannot have velocity in two different directions at the same time. Means whatever position we have shown for ICR, IQR is not correct. If IQR will lie on line joining IPQ and IPR, then it will have velocity in the same direction. Here we can notice if IQR will lie on line joining IPQ and IPR, then VIQR, that is velocity at ICR IQR, will be in upward direction. If IQR will lie on body Q, which is rotating in anticlockwise direction, here we can notice if IQR will lie on line joining IPQ and IPR, then VIQR, that is velocity at ICR IQR, will be in upward direction. If IQR will lie on body R, which is rotating in clockwise direction. Hence, we can conclude if IQR will lie on line joining IPQ and IPR, then it will have velocity in the same direction. Means if there are three bodies which are having relative motion with each other, then for those three bodies we will have three ICRs, and those three ICRs will lie on same line, or those three ICRs will be collinear. This is known as Kennedy's theorem. Hence, Kennedy's theorem states that if there are three bodies or links which are having motion relative to each other, then for those three bodies we will have three ICRs, and those three ICRs will lie on same line, or we can say those three ICRs will be collinear. If you are confused with the stuff which we have discussed so far, then just pay attention to Kennedy's theorem. For three planar bodies having relative motion with each other, we will have three ICRs which will be collinear, or those three ICRs will lie on same line. Kennedy's theorem is also known as three centers in line theorem. If we will go by analogy, then we can say Kennedy's theorem is the heart for ICR method.